Recording in.
All right. So now we are currently, please, if you notice sometime that I'm not recording, interrupt me and just let me know, because I do forget sometimes. All right, but it is recording now. So today, the plan is just to kind of motivate what this course will be about, what we're going to be covering, look at some of the software, and then, of course, the syllabus. So this class, so this is deep learning, right? So this is a deep learning course. So this is deep learning. So what is deep learning? So, well, if you think about it, if this is artificial intelligence, right? And artificial intelligence is just artificial intelligence is the broader field where basically you try to automate what a human can do, right? Anything that a human can do, any problem solving that a human can do, you try to automate through some algorithm or model, all right? And so we've learned that these models, for in general, can be human specified, or they can be models that learn just from data, right? And that's actually what machine learning is. So the difference is that machine learning is models that learn just from the data, okay? Now, if that's machine learning, and some of you have taken machine learning classes, whether machine learning foundations or applied machine learning, at some point during that course, I introduced a specific set of algorithms called deep learning. So what is deep learning then? Deep learning is basically a subset of machine learning that is very powerful. That is something that has become a game changer since about 2012 or so. All right. And so that's what this course is about. We're going to focus on just deep learning and all the deep learning algorithms that are available, because this is really a very powerful tool of machine learning, and therefore, it kind of requires its own course. Does this make sense, guys? All right, great. So that's basically the idea for now. So just so that you understand the big picture. So let's actually start with the syllabus today. And then after that, I'll come back to this page and kind of go over the details here. And then we're going to get into the specifics. So let's start here. So I've gone over this, so there's the Zoom instructions and everything. Hopefully everyone's situated in the correct place. So now everything, the materials will be on here in the content section. Now, currently, if you notice, I haven't added much to the website, and that's because this semester I decided to update the class. So ITS 530 this semester, it's going to run a little bit different from the way I run it in the past. And that's just because, in this field, technology changes so fast. All right, so technology changes extremely fast. So whereas before I was using TensorFlow 1, now the dominant ecosystem is PyTorch for deep learning. So obviously I've switched to PyTorch, but there's even more to that, okay? Given also, I was looking at your backgrounds, a lot of you have taken machine learning already, the foundations. So you've got, or the applied machine learning course. And so you've got some background there. Kyle, have you taken applied machine learning?
Yeah, I think 3 semesters ago.
520, right?
Yeah.
So everyone has taken these classes. Josh, I believe, also has, right, Josh?
Yeah, I did.
Okay, yeah. So all of you have taken 520. And so really, what machine learning is. And so this actually presents us with a very interesting opportunity to take it a step further, right? So I've kind of tailored the course for you guys, and I think you'll really enjoy it. We'll talk about it because it'll basically make you more powerful. And I'll talk a little bit about that. So one thing I would say, I'm not gonna basically start, let's say, from like foundations, and instead I'm kind of starting from really complex problems and working our way back. So you'll see what I mean in a second. Anyway, that's the reason why the table of contents is still not filled in, because I'm going to be updating the course this semester. So let's take a look at, but I have already laid out the topics in the calendar, so we'll take a look at that in a second. So a couple of things. This link is for the course website, of course. So take a look at that. And then let's just start with the syllabus today. All right, so you guys can see everything. So I'm sharing the syllabus now. So this is practical deep learning, and as the name implies, it is deep learning, but it's not a foundations deep learning course. I will be covering the algorithms, but actually my goal is for you to really learn how, like in the real world, how you would apply machine learning, right? So to really understand that sometimes it is actually better to take a model that already exists and use it for your own problem, maybe modify it a little bit, than to create it from scratch. Does that make sense? So we're going to be trying to leverage what very smart people have done and use that approach. Okay, so that's why that's what I'm talking about. So the course is, of course, it's a Monday course from 2 to 5 p.m. We're going to take a 10-minute break. Classes last an hour and 20 minutes. I'll create 2 videos usually, and I'll post them on the YouTube channel. So in general, the course description is that this course covers the theory and technologies related to deep learning. In particular, the course will focus on the following topics. So we will cover obviously the neural networks, right? That's where everything starts. But you guys already in 520, we already covered a little bit of neural nets, whether it was TensorFlow or PyTorch, it doesn't really matter what you took back then. It's kind of the same thing. We just have to, it doesn't really, it's not a problem. So we'll start with neural networks, and just get a little bit of a background on that. I will say this course I will be teaching in PyTorch, and I'm getting away from TensorFlow really. And so PyTorch is becoming like a dominant ecosystem currently. So we'll be switching over to that. But we will cover neural networks, hidden layers, issues in design and with designing deep neural nets. Okay, and this course will be more we'll be seeing a lot of the variants basically, or the different algorithms within deep learning. So that means obviously convolutional neural networks, the CNN, which is usually traditionally applied to images, but not necessarily just for images. We're going to look at recurrent neural networks, RNNs, which are a sequential type of deep learning algorithms. We're going to look at GANs, generative adversarial networks, and we're going to look at a few other topics that I have in the calendar. Additionally to that, we will look at batch optimization and word embeddings, right? And so there's basically like 2 themes in this course. One is going to be like the image-based theme, and one is the text processing theme. And as it turns out, a set of algorithms has more traditionally leaned towards image processing, whereas another set of algorithms has more traditionally leaned towards another set of problems like natural language processing. So we will be looking at both of those, okay? But obviously they can be used for one or the other, and there are other applications as well. All right, so this is just a list of the course objectives, which is pretty much the same thing. The prereq for this class should usually be either the 365 Machine Learning Foundations or the ITS 520 class. Obviously, knowledge of programming up to data structures, Python, Linux. I mean, we can do it nowadays. We can do everything in Windows. On the Windows side, we will actually be using Jupyter Notebooks a little bit more this semester. And of course, knowledge of statistics like probability. You should have taken a course in probability, linear regression to have a sense of that. But I've covered that in 520 or 365 as well. All right, great. Now, books. Are you required to buy a book? I usually say no, but in this class, I would actually advise you to get one book in particular, okay? So can you guys see me, like if I do this, or you can't read this? Huh?
It's getting blurred.
Yeah, it's interesting that it blurs the book. Huh. All right. Anyway, so the books that are available, if you took the 520, you probably already have Python Machine Learning by Sebastian Rashka. You can get that book if you want, but it's not required, okay? There's also the Bible of Deep Learning, so I should mention it, Deep Learning by Ian Goodfellow, Joshua Benjo. These are like the godfathers of deep learning. This is obviously the Bible of it, but it's not a very accessible book. So you can get it if you want to read it, but it's very math oriented. It's not usually a book that I like to, it's very foundations, and we're not taking that approach. So, but if you want to have it for your own library, that's certainly something you can do. Now, the books that I definitely want you to get, and I'm gonna have to hold on. I need to stop sharing, and then I'm gonna need to de-blur this. All right, there we go. You guys can see this now, guys. You can see
yes,
it.
you can.
All right, great. All right, so these are the books. This book, I'm gonna ask you or recommend that you should get, okay? Maybe take a picture of it with your phone or something. It's gonna be in the video, but this book is called Deep Learning for Coders with Fast AI and PyTorch. And if you notice, it's got a catchy phrase there, AI applications without a PhD, all right? And it is by these guys from the Fast AI project, Jeremy and Sylvian. And it's an important book because this is the approach that we are going to take for this course, okay? We're gonna be using the Fast AI library, which is a library on top of PyTorch. So if you think about it, we are doing, you know, Anaconda, Jupyter Notebooks with Python, with PyTorch, and Fast AI on top of PyTorch, okay? So this is a great book, and I'll talk about why I want to do this. So we'll cover this one, okay? All right. So this one, if you're going to get a book, get this one, because I will be following along a lot of this book. Okay, so it's basically the main source. This book, I don't know that you can get online yet. I'm actually reviewing this book right now, but it's a good book. I ended up liking it a lot. It's consistent with this one, and it's about a specific set of very powerful algorithms called a transformer. So although this will be towards the second half of the semester that we will cover this topic, it is really incredibly powerful. Okay, guys? And, you know, who knows what you will be able to solve with this, because it's very powerful. And then the other book that you probably already have if you took the 520 class is this one, Deep Learning with PyTorch. That's by Stevens, Antigua, and Veeman. Okay? Now, of these three books, the only one that I would recommend that you get is this one. Even this one, you don't have to get. I'm not requiring it for anything, but it would be very helpful as I will be using this extensively, okay? Is that clear for everyone? Questions? All right, it doesn't sound like there's any questions, so it seems like that was clear. All right, so let me switch back then to Syllabus. So again, guys, as I said, really that Fast AI book would be the recommended book if you're going to buy one for the class. And then I'll talk a little bit about why I think that's a good way of doing things. Okay. You can see here the topics. Excuse me. The grading scale, as you can see here, we'll have a midterm exam, a final exam. You'll have a term project, which is worth 20% of your grade, and then you're going to have homework assignments, which are going to be just, your basic labs, and how things work there. Okay. So this is just a schedule. So that's basically the syllabus. Okay. If, read through the whole thing, of course, remember key things is please submit a report with your assignment and, where you do like your analysis, your results. You guys understand the pipeline now very well. And then the other thing is submit via Brightspace, okay? Submit via Brightspace. All right. As I said, I haven't really updated this yet, but we will kind of work through this this course in a different way, right? So, and I think it'll be a very valuable approach that we're going to take for this. Okay. All right. So now that we've talked about the syllabus, let's go ahead and talk a little bit about the course website. So you should be seeing course website here. So as you can see here, basically this website is a little bit more updated. So the topics, PyTorch, of course, just playing around with PyTorch itself, Fast AI, etc. Then, of course, the topics, linear regression, logistic regression, neural nets, deep neural nets, autoencoders, convolutional neural networks, RNNs, distributed vector representations, which are something like word2vec, GANs, reinforcement learning, and basically transformers. Okay, so these are the main hot topics right now, or the extremely powerful algorithms in deep learning. Okay. The course is Mondays 2 to 5. I've already talked about the books. Office hours for now, my office is 241, but for now, office hours will be, via Zoom or by email appointment. I will be posting the code on GitHub. You can see the link here. It'll probably be under PyTorch, but I'm going to create a new directory, and I think I'm just going to call it Fast AI, and we're just going to be based off of that. Okay. As I said, we'll be working through this semester. You guys have the backgrounds. We don't need to see anything else. Scholar, as you know, one of the things that we're going to test out today is Scholar. We have Scholar available, but we're also going to take a look at Jupyter Notebooks, and that will be the environment. So Jupyter Notebooks are just Anaconda. So I'll talk about that. All right, and then here is basically the topic. So today I'm kind of just giving you an intro of everything, what we'll be using. We'll talk about performance metrics briefly, since you already should know what this is about. And then, we'll get into deep learning. So as you can see, the first 2-3 weeks are just kind of getting back into it, right? Understanding deep learning from the context of Fast AI and PyTorch. And then after that, we'll get into the specific algorithm. So if you notice, we've got convolutional neural networks, which will be processing them with images. Then we have RNNs, recurrent neural networks, which will be processing first images and then text. N-grams or text, natural language processing. Then after that, we're going to cover word embeddings. And at this point, we'll be focusing more on text. All right. So this class will cover images and text processing, but we'll look at a few other things as well. Then we'll look at autoencoders and their power. Then we're going to get into transformers. Then actually it will be GANs, and then finally reinforcement learning. All right, so that's basically the sequence of topics that you can expect for the semester. All right, are there any questions about this so far? Everyone with me? Just be aware, as I said, most of these videos I will be changing going forward. All right, so I'm not hearing any questions. So then let's just get to it, okay? So the two things I want to talk about today are why fast AI, first of all, why PyTorch, and then the other thing we're going to get into is the software. All right, so let's start with why fast AI. So let's move this here. All right, so here's the thing. When you go to a project, right? You know, there's basically like in academia, right? In academia, you might have a so in academia, let's say that you're doing your master's, you know, some of you are doing your master's, you're doing a thesis or a project, and you have time. You have actually semesters to work on a project. So then you start reading papers, you look at the data, collect data, then you start from scratch building your model, and then you run it, you test it, you get some results, or maybe you write a paper, right? That's kind of the approach in academia. In industry, it doesn't always work like that. So in industry, what might happen is that people want something quick. They want to just get a feel for it really quick before they actually figure out if they want to allocate more resources to it. You know, that's kind of the idea. So at the end of the day, it all has to do with how much time you have available for dealing with a problem, right? And so if you have all the time in the world, you can just go through this approach, right? Like I said, take several semesters to come up with your model, you know, and so on. Collecting the data, cleaning the data will be a very long process. The industry approach is a little bit different in the sense that in industry, you don't have that much time. So you don't really have all that time to really collect data, clean data, try it, you know, fail, try it again, fail, try it again. So what industry wants to do, as you might imagine, is if they want to be quick, is they're going to say, okay, this is my problem. How has someone else solved this? All right, so that's, you know, how did they solve it, first of all? That when they find how they solved it, they're going to say, okay, did they already have data for that? And not just the data, do they also already have a model for it? Do you see that? So instead of you having to collect the data, you know, clean the data, you know, from 520, you probably remember it was very painful to do all of this. Then you model it, you fail, so you keep, you know, iterating, right? And then you build a model and you evaluate, right? So what does your model have? So initially, remember that when you have data, what does a model, let's think of a model. What does a model take as input? What does a model need? It needs three things. What are they? Anyone?
I know samples and features are two of them, but I don't remember the third.
Yeah, so think of it this way, right? A model needs three things, at least. One is the, let's say, the architecture. What does that mean? It just means basically selecting, I'm going to use neural nets, or I'm going to use a CNN. For instance, as an image type of a problem, what are you going to use? A CNN, right? A convolutional neural network. What do you need for that? Data. Once you have the data and the architecture, what's going to happen? The model learns. Remember, learning just basically means the weights. Do you know what I mean by that? So basically, you define, so for instance, let's think of a neural network, a simple one, right? So we take some inputs, we have a hidden layer, and then we have the output layer. What do we need to predict whether it's this class or that? We create the architecture, right? We have the architecture there. That's the architecture. But we don't have weights, right? So initially the weights are zeros, they're random, but eventually they become, 0.07. That's the right value. So we know the weights. So once we have the architecture, once we have the weights, which come from the data, then we have a model. Do you guys see that? So this is what we need to be really quick. So in industry, they don't want to take the approach of, I'm going to start by selecting a model, then I'm going to get the data, then I'm going to take the weight, learn the weights. It's going to take me a long time because I have to fail multiple times in my model, right? You're going to fail a lot until eventually because you need to get, reiterations of the weights, reiterations of the data, and that takes a long time. So in industry, what you want to do actually is you want to say, I have a problem. So let me go over here. So now in industry, you want to say, I have a problem, whatever it is. You're trying to predict images, cats and dogs, etc. All right. And you really want to start as quickly as possible, as you possibly can. So then what do? You go and you find, for this specific problem, this architecture worked. Call it a CNN. They already have this data set, which is really good. But also, they already trained it. They already have a trained model. So that means the weights are also available. Does this concept make sense, guys? So basically, for any problem that you have, you want to find, now, are you going to have a model already trained for every problem? No, but you will have some generic models, right? And so we'll talk about that. So that's what I want you to understand with the course this semester, Practical Deep Learning. We're going to take, instead of the more academic approach, where you kind of, would do this whole pipeline and then maybe, define everything. We're going to take the more industry approach, which is a little bit like this. Okay, now, obviously, I'm still going to cover I'm still going to go in depth and tell you, explain to you what a CNN is in PyTorch and everything. I'm not saying I'm not going to do that. I will do that. But I'm just saying we're taking this approach that as an industry, we would want to start here, get some results, and then we're going to get into, let's say then you decide, okay, it works well, but I want to do some modifications. Well, obviously now you have to get into the specifics of a CNN. So what I want you to understand is that the difference really between like the academic research approach versus the industry quick approach is that in both of them, you have a model. In both of them, you get some data. But here's the difference. The weights here are already valid in this, let's say this is the industry one, this is the academic or research approach. Here you totally learn the weights. So here you're just gonna learn the weights, okay? Learn the weights from scratch, basically. Let's say that from scratch. Whereas here, you start with good set of weights. Do you guys see that? you actually start already with a working model. Are there any questions about this idea? No? All right, so can you guys hear me?
Yeah, we can still hear you. Just no questions.
All right, great. So this is important, okay? This is an important idea, and this is the idea that we're going to take. So now here's the thing, though. The model may not work exactly for your problem, right? But at least it's a good baseline. It's like, okay, we just take that model, we modify our data a little bit, run it through it. How does it do? Okay. Now, this idea then takes us to the concept of transfer learning. And this is basically what you want to do. So in industry, you want to apply this idea of transfer learning quite a bit. And so what you do is, again, you have the problem, right? And then you find the model where you already have data and weights. You apply it to your data, right? So this is your data, let's see over here. So your data, it's over here. So you're going to apply the model and then get some results. However, the results may not be so great, right? So then what do? Within the concept of transfer learning, you're now going to take your data and you're going to basically cut it in, do the split, right? Train and test. So now your data will also be used to train the model. So that's the transfer learning part, is that the model initially already had some weights from another data set, because that other data set was learning how to do, classification between cats and dogs, right? So that model already could do that. But you don't want to classify between cats and dogs. You want to classify between bears and eagles, right? So you want, or elk or something like that, right? So you want to, it's an animal classification, but not exactly. Do you see that? And so now, would you agree that, bears and elk versus cats and dogs, they're similar, right? They're similarities, they're animals, they have, the backgrounds are always trees, they have legs, faces, fur, right? So there are similarities, but it's a different problem. So that's where transfer learning comes in. You find a model that works, it's got some weights that are already kind of good, and then you just add a little bit of your data to kind of finish up the training, to have it be a little bit more specific for the data, for the problem that you're trying to address. And then, of course, you should leave out the test set, which is your own data, because that's the holy grail, right? So it's got to do really well on this data set, if that makes sense. Okay, and that's basically, this concept is called transfer learning. It's very important in industry. It's not really that, you guys understand, I'm sure, but that's the approach that we're going to try to take, because at the end of the day, what I want us to do this semester is I want us to be really fast at solving deep learning problems. I want you to have, before you probably knew it takes a while and you have to get the data and all that stuff. Here this time around, or you were just playing with like MNIST or something, which is not great, for all problems, right? So this time around, with this class being, you guys have a great background and it's a more advanced course, I want us to really take it to the next level, okay? And so while we do that, we will explore a lot of the deep learning algorithms that are appropriate for specific types of problems, and always trying to take this transfer learning approach, basically. The library that will facilitate this, and the reason why I chose this book deep learning for coders with fast AI and PyTorch is, as the name implies, fast AI, you know, AI applications without a PhD. Basically, the idea is exactly this. In industry, apply transfer learning as much as you can, and then learn how, once you have a model that works, how to adapt it to the specific problem that you have, and then get good results so that you can just go by, you know, hopefully not by the end of a week, but within a really quick process, you just show, okay, here's how it does, kind of with the state of the art right now. Okay, so that's kind of the idea. So usually that's, as I said, that's going to be the library fast AI, which is up on top of PyTorch, and PyTorch, of course, on top of Python. All right, fast AI is really great. So one of the things that we will do this semester is kind of learn, we have to learn kind of how fast AI works. My suggestion with fast AI is as we start going through the lectures, or as you start going through the book, if you get it, start creating a cheat sheet. That will actually really help you, because a lot of the time with fast AI, you just have to know all the different functions that are already available for us to do some of the processing. We'll of course have to install fast AI and all of that. All right. Any questions so far? All right, so anyway, so we've covered the topic of transfer learning, and now let's talk a little bit about the architecture of this. So you guys know that in deep learning, you have architecture, right? So let's say, for instance, let's take PyTorch, and then let's do fast AI over here, if you will. All right, so let's say that let's take the classification problem of images, right? Let's actually stay with that example: cats and dogs, bear, eagle. So let's say that you find the optimal architecture, right? And it's got, I don't know how many layers, many, right? And we're going to learn that CNNs are actually, let's say this is a CNN, and it's fairly complex algorithm that we have to, or architecture that we have to learn about. But what's important is it's got all these layers, and then it's got one final layer, sometimes called a fully connected layer after the CNN layers. These are the CNN layers, filters, etc. And then this is the classes, basically, right? The two classes. So what happens again, what happens with transfer learning is that this was for cat and dog, right? With transfer learning, you would basically leverage this architecture up until a specific layer of the network. Okay, guys? So you would leverage, this is still a CNN, which we have to learn about that, of course. I'm kind of just giving the big picture today, so don't worry about the algorithms. But now, in fast AI or in transfer learning itself, let's say this is transfer learning. Okay, now here we would use, basically, we're going to use the model, but we can't use the entire model, obviously. There will be some things that are specific to the problem. So this is cats and dogs, whereas this other one that we're trying to solve now is bear and eagle. So some of my point is, some of the layers of the neural network will have to be changed, okay? Some of the layers will have to be changed, and it's usually the last layers. It could be just the one last layer or the few last layers, okay? Now, of course, we can do this strictly speaking in PyTorch, right? You can just grab the code and just change it, modify it to your own goals. Or fast AI actually just kind of implements this for you. All right, but the basic idea is that we reuse a lot of the model here, and then it's usually just like the last segment of it that's going to be changed to be specific to that particular problem that you're trying to solve. Okay. Now, intuitively, why is it that these few layers, you might ask yourself, why is it that these layers, let's say from the beginning to here, why is it that we can reuse those? And that just has to have, that just happens to have, is based basically on the way that neural networks work. Okay. The way that neural networks work is kind of like this. So, you know, you have, let's imagine we have a network like that, right? And so, and then here is like where it diverges. So I go back. Right, so that's where it's going to diverge for the other. So what's the intuition? The intuition is that if I kind of draw this as images, this might be the image of an animal, right? An animal there, some kind of animal. So this is the input that goes in here. That's the first input. What happens in the first hidden layer is that neurons are engineered, right? So let's take, for instance, this feature here. That feature depends on the inputs of the image. If we tried to intuitively visualize what has happened to the image given this layer here, we might say that in this image, the algorithm has learned to identify little curves like that. You see that? It has learned to, and this had an eye there. So it has learned to identify little curves. In the next layer, it's going to be based on these inputs, right? So it's going to be based on these inputs. So if we intuitively try to imagine what that image would look like, what the classifier is doing, we might see that it kind of created an ear. It kind of identified an ear there. It kind of added a little bit of more shape to the eye. Do you see that? And other things might be in there. Then in the next layer, well, now it's using the information from the previous layer. So it might turn out that in the next, if we try to intuitively associate this to the layer, it found a face. It identified ears with eyes and a nose and a little bit like this. And it's saying, I know that to be the head of an animal. So at this point and this is just an example, but at this point at layer 3, one of these, maybe this feature, has basically, it's going to fire every time that it finds a face in the picture, the face of an animal, not the face of a human, but the face of an animal that has this profile over here. Does this make sense, guys? And so if you think about it, this entire architecture will work well, whether it's a bear, a cat, a dog, or even an eagle, right? An eagle will have, I don't know, something like that, right? So it still has like an eye, you know, it may not have an ear. So it'll probably, the algorithm will not do as well with eagles as it will do with the other ones. But still, the intuition is that why with transfer learning, you don't need to learn these layers if they have already been learned by another model. Okay, if another model has learned these layers, then there's no need for you to learn them again. First of all, because if you're taking the state of the art, that means that they probably had a data set of millions of faces of animals, which you may not have. You see that? And so you want to leverage that state-of-the-art data set because they already have learned these hidden layers, not the ones that find if it's a bear or a cat, but the ones that kind of find eye-ear combinations to identify an animal face. That part of the network is really good for you, okay? And so then all you have to do is then you would use these layers up until here, and then you learn your own. So if you notice then, the architecture, you know, I'm not doing all the connections. But these weights, let's call it weight set 1, weight set 2, weight set 3, weight set 4. Those are weights that you can reuse. And in fact, they are probably the most optimal weights. Even you, with all the machine learning that you can or can't do, you would not be able to achieve that performance. Do you guys see that? So that's transfer learning. Now, the issue is these connections over here are the ones that you have to kind of learn with your data. So you'll have to, put in the architecture, and this is another set of weights. Let's call it in green W5, W6. Those weights you want to learn, because those are going to be more specific now, not to, to your problem, bear or eagle. Okay, so when you do the training now, you want the algorithm to don't update these as much, right? So the goal is, you know what, those are solid weights, don't really update them that much. Focus most of the updating on these weights. So you can see, you guys have done PyTorch or TensorFlow. You understand how you would do this with those languages from scratch. But the advantage of using something like fast AI or a transfer learning, transfer learning focused approach is that the library is kind of designed for that. So it's there to help you out. And so that's really sort of the beauty of it. Okay. So that's it. I mean, this lecture today, this is really the most important thing. Everything else, it's like, yeah, this is how it's done, or, code this like this. This is X and Y. But really the thing that I wanted you to understand was this idea of transfer learning and how, what the intuition behind it. Okay. That at the end of the day, your model will never be as, your model will probably never be as good as this part here, just because those weights are optimized with the state-of-the-art data set. So again, that kind of then takes us to the idea that I told you about. So we have a model, and let's say it's a CNN. So then that CNN is going to have two things, the data, but now the weights are very much a thing that you want. Okay, it's, you want to leverage that power, and then after that, with your own data, you need to, as I said, modify the architecture a little bit with the green part, and also that's the most of the learning will happen on that set of weights towards the end, so that you can be more productive, faster, etc. And so really what we're going to try to do this semester is we're going to try to take those approaches, all right, of really quickly trying to solve a problem. Fast AI does provide a lot of data sets, which is really great. And it will provide us basically, hopefully with models, and then we're just going to apply those models to other problems and see the performance, which in theory should be way better than anything you could have done. So let's say, for instance, that's one of you is working on network intrusion detection, right? So Kyle, I'm going to pick on you. What would be your approach to network intrusion detection?
You would want to figure out what constitutes network intrusion detection. So one way you could do that is like if certain types of network traffic are sent at certain times or in certain like bursts, I guess. Yep. You could learn off that.
All right, so that's your approach. And then now, knowing what you know about what I just said about transfer learning, what would be your approach?
So I would try to find somebody who's done this in like a big, or with a lot of data, I guess, and then apply what I would use in terms of like devices or something to what they did.
Yeah, exactly.
Or like at the tail end.
right at the tail end, right? So you want to, it's no longer, remember, before I would just say get the data. Now I'm not going to say get the data. Now I'm going to say get the data, get the architecture, get the weights. So I literally want you to leverage someone else's model. And then you're going to do this last bit over here, and you're going to, and hopefully in theory, your model, you'll be much faster, much leaner, much better. And still, Fast AI is still built on top of PyTorch, so you can still do this eventually from scratch. But now you have just this better, speedier, and better approach. Okay, so that's kind of the idea. So hopefully that makes sense. All right, great answer. So now, now that I've talked about this, one big place. So like I said, a lot of the problems this semester, will be like images. And a lot of the problems will be text. That's just because of the nature of it. So the two main algorithms that you use for images is CNNs. And then remember when you've done deep learning, you always had this question, okay, so how many layers? Am I gonna do 2, 3, 5? Well, you no longer have to worry about that either with transfer learning, because you just go to the state of the art and you literally say, this was the architecture that they used that was the best. So you actually, remember, you bring in that model. Fast AI will give you names for all the, different architectures even. So it's no longer about just saying 2, 3 layers, but it's about saying this specific layer, which has 32 layers and so many filters and so on. Okay, so all of that is a little bit, everything basically is now more precise, more the state of the art, etc. So for CNN, for images, we're going to be using CNNs and GANs. Oops. GANs. For text, we're going to be using encoders, autoencoders, or vector representation. So distributed vector representations, so word2vec, and transformers. RNNs are a topic that I'm not going to cover that much of because they have been kind of replaced a little bit by transformers, and the transformer is the more interesting, more powerful algorithm. If you remember, one of the books that I mentioned was this book, Transformers, which I showed you before. Like I said, I don't know if this book is available, but it takes that same approach. So nowadays the transformers have names. So basically, because like Google developed one and Facebook developed one, so you'll see things like Bert, Roberta, and GPT-2, GPT-3, and so on. So this is the same idea, right? The same idea. Somebody took, we'll cover what a transformer is. It is actually, I should say, the transformer is the most complex deep learning algorithm there is. I mean, it's complex without a doubt, because it uses a lot of things, but it's actually incredibly interesting. It works in unsupervised environments. That's the beauty of it. So you don't have to have millions of labeled information necessarily. You can actually leverage without. It's great for translation, right? So, for like language translation, etc. So we'll take a look at that. But the idea is kind of the same. These things like GPT-2, GPT-3, etc. What are they? Same thing. If we think of the transformer as just a deep learning algorithm, right? So we have a transformer, a deep learning algorithm. And let's say Google or Facebook, they trained it on, imagine all the data that they have, right? So they trained it on all their data. and then they got all the weights. So what GPT-2, GPT-3 are is just different versions of a transformer that has been trained on some Google data. Imagine you don't have, I mean, there's no way that you will ever be able to train a transformer with more data than Google, for instance. And you guys know that, right? And also it took Google a lot of computing power to crunch it, right? And so getting those weights would be a lot harder for you. And so what you want to do basically is that nowadays people just say, I'm not just going to use a transformer, I'm going to use GPT-2, or I'm going to use GPT-3 or BERT or Roberta or whatever. And what they mean by that is that they're taking a transfer learning approach. They're going to take a transformer with an architecture that has already been defined. It has been trained on a data set. It's got a set of weights. And then now what you can do is the same thing. You can now show it. You know that, let's say, for instance, you build a transformer that translates English to Spanish. Well, you can start with that, and then you have your own data for your own regional area of the world, right? Where you speak something like that, or, you know, the United States, right? Where there's got to be a specific way of versus Europe. So now what you can do is, in Europe or in America, you take the original transformer, but now you start giving it some of your own local data. And then the transformer will just adjust some of its weights to this specific data set. So it's already very good. It will be very good at translating certain things, and then it just has to become better at some of the subtleties. So again, this will do a lot better than anything that you can train, even though building a transformer from scratch might still give you pretty good results to you. Okay? So I mentioned this because it's kind of important that you understand that there's actually already in transfer learning some of these algorithms with their weights and data that have even their own unique names, if you will, and they're extremely powerful. Okay? All right, so I think that's it as far as just kind of giving you the intuition of how the class is about. So are there any questions, I guess, before we continue? No questions? All right. Okay, great. So if there are no questions, then that's basically the intuition. So we've covered the syllabus, we've covered the calendar, and we've covered the basic idea. Now let's get into the specifics of the tools, the environment, and then after that, we'll just get a little bit into, you know, the code. So let's go ahead and stop this. All right, let's go to here. All right, and now then, so two things that you should do. One is set up Anaconda. Now, I'm assuming most of you have Windows computer, right? So it should work with that. We also have in the Linux environment, we have Scholar. So let's actually, I think your accounts have been created, but let's go ahead and try that. So you click on Scholar here, right? And then you're gonna click on Remote Desktop. Okay, and then just log in. So I need to use for this my boiler key. And I want you guys to also try this and let me know, because I need to make sure that you have access to Scholar. So let me stop recording. Sorry. So we are now recording. So let me switch over back to, let me repeat that. So, let's just go back here, right? So to table of contents, and then click on the link. And then if you click on Scholar, right, it takes you to these two. So now we have remote desktop, which is, we can log in, we get a terminal and everything. You can also click on Jupyter Hub. You should have access to that, was my understanding. And then this actually, if you notice, the desktop environment, 365, 520, fall 2021, Anaconda there, should be consistent with this, right? With the environment that you have in your Scholar desktop, if you will. You got the 365, old, fall 2021, Anaconda, 520. But now this opens nicely in a Jupyter Notebook type of environment. So it opens on a web browser. So this is sometimes convenient. So really we have both ways of doing this, right? And really, if we write code in Jupyter Notebook, we can always save it as a Python script. So we could generate it here and then save it as a Python script and run it on the command line in Scholar. So either one will work. That's not a problem. What's going to happen is if we go to desktop, I'm going to click on new, and you can see it's got all these versions of Python. So probably Python 3. Don't use 2.7. So probably like Python 3.7 would be a good one. And it basically opens up something like this. Okay. Is there a question? Yeah. So I'm assuming if your Scholar doesn't work currently, your Jupyter Notebook may also not be working. I'll have to talk to them. Hopefully it's just that the batch hasn't been run yet, but usually it should have done it overnight, and I did this last week. I'll have to see. In any case, currently I'm just showing, I'm not really going to go over that much code today. I'm just really showing you the environment and hoping that you guys are familiar with it. So you're either going to use Scholar like this, right? Remember, you just open a terminal, right? When you open the terminal, you have to do bash, remember? And there you go. Once you're in this, once you're in bash, you're going to then, you can do like conda environment list. Right, and then notice here I have several environments, like I have PyTorch 3.6, which for those of you that were in 520 last semester, you're probably familiar with that. Otherwise, we'll have to set it up. And like I said, scripts here, we can write the code, or we can write the code on Jupyter Notebooks here. And basically this is, we can write our Python. So let's say A equal 3, print A, right? And so if I hit run, basically it just prints 3. So that's basically all it is. So I'm just trying to be consistent with the book, since the book does use Jupyter Notebooks. And so it'll just make it easier to kind of follow along exactly like that. Does this make sense, guys?
Yep.
Okay, great. Now, the other thing you can do is, although I'm providing these resources for you, there's no reason why you can't just use your own machine, right? So you can also just use your own computer. And in fact, if you have a Windows computer, Mac, etc., as I said before, just go to the course website, click on the link. Or actually, I forgot, just Google this, Anaconda. Right, click on that. And this is basically the library, the site, right? So you can just go to the bottom. Or not. I think it's individual. Right. And then you can just find look at all the libraries that it includes. So Jupyter, which I just showed you, NumPy, Pandas, sklearn, TensorFlow, PyTorch, Matplotlib. So a lot of these are the libraries that we usually use in machine learning. We'll just have to make sure that we've got Fast AI set up correctly, because Fast AI is its own Python library. So then you'll just let's say on your Windows environment, you can just go ahead and install whichever one you want there, and you'll be all ready to go. Does that make sense? So how many of you, although I'm going to try to get all of you to have Scholar set up, because I already requested it. How many of you think you have a computer that you'll just use your own computer? I just want to like gauge.
I have my own computer I can use.
Yeah, so you'll just set it up on Anaconda, right? And then, yep. And then who else?
Yeah, I'll probably do the same.
Ryan, okay, Kyle, yeah. And then Jeremy, you'll use your own. Right. Yeah, so, right. So that's probably the best idea. And then I'll just use my own as well. So I have Conda here, right? So now I have to, so usually you just say Jupyter. There it is. So you guys are seeing this, correct? Okay, you can't see that. So let me do that again then. And so just type, once you've installed it, just type Jupyter. And then it'll open up on your own machine. Right. And then you can see this is my directory structure on my own physical computer. So I'm going to go to the desktop. Right. And then in here, you know, you can just create a folder that's specific for the class. So I'm actually going to do that right now. So let's call this one ITS 530 DL. This is what, spring. I'm just going to say 2022. Okay. So I've created my folder. I recommend that you do that as well, so that you don't lose your code. So usually after class, whenever we finish the script, etc., I'm going to load them up to the GitHub, but it's good that you have your own. Or sometimes I may just provide the script beforehand and we'll just read through it. So now, there it is, ITS 530 DLL 2022. So you can see it's empty. I'm going to open up, I'm going to select Python 3. I assume you guys can see. You guys are seeing what I'm doing, correct?
Yes.
And then, so just click on Python 3 over here, and there you go. So this is kind of how it works. As we go through Jupyter Notebooks, practicing some exercises, we will be basically viewing. But as I said, now you can code something you know, import NumPy as NP, for instance, right? So these are the kinds of things we want to do. So you want to run all these checks just to make sure that you have the libraries, okay, that you're going to need. So remember, for this course, we're going to need NumPy, Pandas, sklearn, and PyTorch, and FastAI. But then remember, the nature of data science is that you're constantly adding new things, updating things. So you got to be flexible with that, okay? Now, that's why I like using either Scholar or just your own machine, because having administrator privileges is pretty important. Everyone with me so far, guys? Is it making sense? All right, so, okay, great. So I think it's making sense. So it's 3:20. I'm gonna take a 10-minute break. I'm gonna end this video now so I can start generating it, so I can post it on YouTube later tonight. And then we will come back at 3:30, okay? So we'll take a 10-minute break and then we will come back. Does that make sense?
Yep.
All right, I'll see you guys in 10 minutes.